Hello everyone, welcome to this new set of tutorials about trigonometry. First, let's start with this basic question of what trigonometry is and what are its applications in the real world. So trigonometry simply means calculations with triangles. It is a study of relationships in mathematics involving lengths, heights and angles of different triangles. Trigonometry spreads its applications into various fields such as astronauts, surveyors, physicists, engineers, architects, and even crime scene investigators. So in this part of tutorial, we are going to learn about circular function, mensuration of a circle. Circular functions, measurement of rotation. When a line OP is pivoted at O, and rotates from its initial position OP0 to a new position OP1, the angle P0 OP1 is a measure of the rotation of OP. The angle theta is usually measured in one of the two units. The first one is the degree. The ancient Babylonian mathematicians, because they thought that the solar year was 360 days long, divided one complete revolution into 360 equal parts, each part now being known as 1 degree. Using the degree as the unit of rotation, half a revolution corresponds to 180 degrees and quarter of a revolution, that is a right angle, corresponds to 90 degrees. Angles smaller than a degree are usually given as decimal parts. Example, half a degree is 0.5 degrees. But in some fields, for example navigation, a degree may be divided into 60 minutes and each minute into 60 seconds. The radian. If an arc P0 P1 of a circle is drawn so that it is equal in length to the radius of the circle, then the angle P0 OP1 is called 1 radian. The number of radians in one complete revolution is therefore given by the ratio circumference over radius. But the circumference of a circle of radius r is of length 2 pi r. Thus there are 2 pi r over r equals to 2 pi radians in one revolution. That is 2 pi radians equals to 360 degrees. Further, half a revolution is pi radians, which equals to 180 degrees. And one right angle is pi by 2 radians, which equals to 90 degrees. When an angle is quoted in terms of pi, it is normal to omit the radian symbol. Thus, we would write 180 degrees equals to pi and not pi radians. Other angles which are simple fractions of 180 degrees can easily be expressed in radians in terms of pi using the relationship 180 degrees equals to pi. For example, let's take 60 degrees. If we need to write 60 degrees in radians, so we divide 60 by 180 and then times it by pi to get the radian value of 60 degrees. And conversely, to write 7 pi over 6 in degrees, we times it by 180 degrees and divide it by pi, and we'll be getting 210 degrees as the answer. Mensuration of a circle, which means we are going to have some measurements on a circle. So in order to understand the measurements of a circle, we need to recall the knowledge about circles. For example, the circumference of a circle, which equals to 2 pi r, and the area of a complete circle is pi r square. So these formulae can be used to derive further results such as the length of an arc and area of a sector. So let's get into the length of an arc. Consider an arc which subtends an angle theta at the center of a circle, where theta is measured in radians. So the diagram clearly shows the angle subtended by the arc is theta radians. So from the definition of a radian, the arc which subtends 1 radian at the center is of length r. Hence, an arc which subtends theta radians at the center is of length r theta. Area of a sector. The area of a sector containing an angle of theta radians at the center can be found by considering the sector as a fraction of a circle. The ratio of the area of the sector to the area of the circle is equal to the ratio of the angle theta contained in the sector to the angle 2 pi contained in the circle. That is, the area of sector over pi r square equals to theta over 2 pi. So by multiplying both the sides by pi r square, we can find out the area of a sector, which equals to half r square theta. So we can notice in the diagram that the area of the sector is shaded in green, which equals to half r square theta. So theta is the angle subtended in the center of the sector. Hence, if an arc AB subtends an angle theta radians at the center of a circle of radius r, the length of the arc AB equals to r theta and the area of sector AOB equals to half r square theta. Now pause the video and try out this question by yourself. Okay. A railway line changes direction by 20 degrees when passing round a circular arc of length 500 meters. What is the radius of the arc? Now if we draw a diagram in order to figurize the information given in this question, we can notice change in the direction of the railway line is 20 degrees and the length of the arc is 500 meters. So we are asked to find out the radius of the arc. So the length of the arc equals to r theta, where theta is in radians, and as we have the angle in degrees, we need to get it in radians. So that we multiply 20 degrees by 5 radians and then divide it by 180 degrees, which leads us to pi over 9 radians. And by substituting the relevant values in the equation length of the arc equals to r theta, we may get 500 equals to r times pi over 9. And by solving the equation for r, we get r equals to 4500 over pi. And further simplification, such as substituting 22 over 7 for pi, working out for r would give us the radius of the track as 1432 meters. Now pause the video and work out this question by yourself. Chord AB divides a circle of radius 2 meter into 2 segments. If AB subtends an angle of 60 degrees at the center of the circle, find the area of the minor segment. So if we draw some diagrams using the information given in the question, so we can notice the chord AB is drawn over here and it subtends an angle of 60 degrees at the center of the circle. As the chord divides the circle into 2 segments, we get a major segment and a minor segment. And we are asked to find the area of the minor segment. So we separately take the sector and the triangle, which is formed using the chord and the 2 radii of the circle. So we learn that the area of a sector equals to half r square theta, and the general equation to find the area of a triangle is half times the base times and the perpendicular height. So here we need to find the perpendicular height of this triangle. So let us name the point which connects the line from A to BO as C. So the length of AC equals to the perpendicular height. Therefore sin 60 degrees equals to AC over AO. And AC equals to AO times sin 60. So we know the value of AO is 2, which is a radius, and sin 60. So we write the angle in degrees in radian values. So 60 degrees equals to pi by 3 radians. And the area of the sector AOB equals to half r square theta. And by substituting the values of the radius and the angle, we get half times 2 square times pi by 3, which equals to 2 pi by 3. And by substituting 22 by 7 for pi, we get 2.094 meters square for the area of the sector AOB. To find the area of the triangle AOB, we have found the perpendicular height AC equals to 2 times sin 60. So by substituting those values, we get half times 2 square times sine 60 degrees, which equals to 1.732 meters square. And finally, by taking away the area of the triangle AOB from the area of the sector AOB, we get the area of the minor segment, which equals to 0.362 meters squared. So that's it for this tutorial. I hope you enjoyed learning about circular functions and mensuration of a circle. In circular functions, we learned that there are two measurements used to measure angles. One is the degree and the other is the radian. Then we got to know that a complete revolution corresponds to 360 degrees, which equals to 2 pi in radians. Then half a revolution corresponds to 180 degrees, which equals to pi radians. And a quarter of a revolution corresponds to 90 degrees, which equals to pi by 2 radians. Then we converted angles in degrees to radians and vice versa. Next we learned that the length of an arc is r theta if the arc subtends an angle theta at the center of a circle of radius r. And with the same conditions, the area of the sector equals to half r square theta. So if you like this tutorial, press the like button and also subscribe to this channel so that you get all the tutorials as soon as they are posted. Stay tuned. Thank you.